All right, so these are going to be our notes on standard position of an angle, coterminal angles, and reference angles. So definitions are already written out for us. Standard position of an angle is the vertex that's located at the origin, and we're going to have one ray on the x-axis. So for example, if I have my coordinate plane here, standard position again is saying that I will have one ray here on the x-axis, and then I will go either clockwise or counterclockwise to create an angle. So that's my standard position. Like I was just saying about counterclockwise and clockwise, when we have a positive angle, we will be going in the counterclockwise direction. So for example, like this. And then if we have a negative angle, we're going in the clockwise direction. So like this. So again, we'll start on the x-axis and we'll go counterclockwise. So positive and negative angles, that's the difference. That works for both degrees and radians. This is just a quick review. Our different types of angles. We have acute angles, which are less than 90, obtuse, which are greater than 90, right angles that are equal to 90, and our straight angles that are equal to 180 degrees. Now, we have our four quadrants here, quadrants 1, 2, 3, and 4. We should know that, hopefully. But one thing I want to note here is talking about different sides of our angles. So let's say I do have an angle that looks something like this. So I'm starting here and I am ending here. This side right here that I'm starting on, we are going to call that our initial side. And this side is always on our positive x-axis. And then right here, we have our terminal side. And so this is like the ending side of our angle. So initial means the start, terminal means the end. And we'll see that more when we talk about different parts of angles. So these examples here, we're going to draw the angles. We're just kind of going to sketch them and see which quadrant they fall into. So 45 degrees, that's less than 180 degrees, and less than 90 degrees, it's halfway between. So it should be about here. And so this will be in quadrant number 1. Again, because it's positive, we'll go in the counterclockwise direction. 225 degrees, again, we'll have our starting line. I know I'm going to go 90, 180, and then I go another 45 here about to give me 225 degrees, and that will fall into quadrant number 3. Now I have theta equals negative 135 degrees. So this time again, I will still start here, but I will go in a clockwise direction. So this will give me a negative 90 degrees here, and I still have to go negative 45. So I'll go backwards about halfway here. And so this will also be in quadrant 3 for negative 135 degrees. And then 405 degrees, as we can see, this is greater than 360 degrees. So we're going to make one full rotation here. So I'm going to start, go one full rotation counterclockwise. So that's 360 degrees. So if I subtract 360 from this, that leaves me with 45 degrees. So I just go 45 more degrees from this point here. And that will give me my angle. We indicate that it's greater than 360 degrees by having that circle go around more than once. And that will be our angle. We're going to do the same thing here in radians. So pi over 6, that falls into, oh, well, this one falls in quadrant 1. Forgot to mention that. So pi over 6, that's going to be less than pi. It's going to be less than pi over 2. So it's going to be in quadrant 1, somewhere around here. And so that's going to be our angle, positive again. Next, we have negative 2 pi over 3. So we're going to be going in the clockwise direction. Now, negative 2 pi over 3, that's going to be less than negative pi, but more than negative pi over 2. So therefore, this one will fall somewhere in quadrant 3. And then 8 pi over 3. What we can see here is that this is actually going to be greater than 2 pi. So if I was to subtract 2 pi from this, I can get a common denominator of 3. So 2 pi will be equivalent to 6 pi over 3. That's going to be equal to 2 pi over 3. So again, I'll start initial side. I will make my full rotation around, and then I'll go 2 pi over 3 after that. So that will put me in quadrant number 2. And then lastly, 11 pi, or not 11 pi, 13 pi over 6. Do the same thing. I can see that that's going to be greater than 2 pi. So now I'm going to subtract 2 pi, which is going to be the same thing as 12 pi over 6 to get that common denominator to give me pi over 6. So I'll make my full rotation around and go pi over 6 further to create my angle. And this one also will fall into quadrant number 1. So next we have our coterminal angles, and we're going to tie this into what we just did there. Coterminal angles are going to be angles with the same initial and terminal sides. So essentially, they're going to start and they're going to end at the same exact place, no matter how many rotations they make clockwise or counterclockwise. It could be 1, it could be 2, it can be 1,000. It doesn't matter, because as long as we go around that full rotation, it's still going to start and end in the same place. And that rotation can either be in degrees, being 360, or in radians, being 2 pi. So if I was to look above and see what coterminal angles I have, I see that angles 1 and 4 start and end in the same place. The only difference is that angle number 4 made one full rotation around, and angles 2 and 3 are also coterminal. The only difference is that one is negative and one is positive, but despite that, they still start and end at the same place. And then if I look at my bottom section here, angles 8 and 5 are the same, because one is just pi over 6 and the other is just an additional rotation around, which is 13 pi over 6. So essentially, just like what it says below, an angle of x degrees is coterminal with angles of the form x degrees plus 360k, where k is an integer. So that's just saying I'm either going to be adding or subtracting 360 degrees, or adding or subtracting 2 pi if we're in radians. So if I was to find a coterminal angle that's less than 360 at 420, I would go ahead and subtract 360 degrees, which would give me 60 degrees. So 420 and 60 degrees will be coterminal angles. Number 2, it's negative 120, so I'd have to add 360 to that. So that would give me a positive 240 degrees. So again, negative 120 and positive 240 are coterminals. I have 20 pi over 9. That's more than 2 pi, so I'm going to subtract 2 pi. And equivalent to 2 pi with a denominator of 9 would be 18 pi over 9. So then I get 2 pi over 9. So 2 pi over 9 and 20 pi over 9 are coterminals. And then this one's a negative 3 pi over 4, so I'm going to add. So I'll add 8 pi over 4, and I will get a 5 pi over 4. So for this last one, 5 pi over 4 and negative 3 pi over 4 are coterminals. Again, just because for each one of these I only added or subtracted one full rotation does not mean those are the only 2 possible coterminals. I can add another 2 pi or add another 360 if I need to. Again, there's an infinite number of coterminals depending on how many rotations you want to make. But sometimes we'll have cases where some are more useful than others. All right. The last thing we're going to do here is reference angles. So reference angles are formed by the terminal ray of our original angle and then the x-axis. And these angles will always be acute and they will always be positive. So the best way to do these would be through examples. So if I have 165 degrees here, that angle will put me in quadrant number 2, and that would be a rough sketch of this angle right here. And so my reference angle for this will again be between my terminal side, which is right here, and my x-axis, which is down here, the x-axis closest to that one. So my reference angle is going to be this angle right here. Now we know our original angle is 165 degrees, which means this sliver right here is going to have to be 15 degrees. Because again, this first half of our angle of our circle, we can think about it like that, would be 180. Subtract 165 from 180, we get 15 degrees here. Now we have 23 pi over 9. If I was to do this one here, I'm going to go ahead and figure out what would be left over, because we can see 23 pi over 9 is going to be greater than 2 pi. So I subtract 18 pi over 9. That will give me 5 pi over 9. So I'll make my full rotation around, and I'll have 5 pi over 9 left over, which will put me in quadrant number 2. So that's going to be my original angle here. And then my reference angle is going to be, again, with my terminal side here and my x-axis here. And so if I went 5 pi over 9 additionally in this section over here, to create this semicircle we have, I would have to add another 4 pi over 9. So 4 pi over 9 will be my reference angle. Continuing on here, we have a negative 40 degrees. So negative 40, I'm going to go clockwise, down 40 degrees. And I can notice that my terminal side will still be my terminal side, and the closest x-axis is the original x-axis we had. So this will also end up being 40 degrees. But this time again, because reference angles are always positive, our reference angle will be a positive 40 degrees. And then lastly, I have this negative 19 pi over 12. So again, I'll start my initial side. This is going to be at least half the circle here. And then that will leave me with 7 pi over 12, which will put me back into quadrant 1 over here. So if that is 7 pi over 12, the remaining section here will have to end up being 5 pi over 9. Now, additionally, we could get this through coterminal angles, but we'll talk about that a different day, or if you have questions, you can just go ahead and ask in class. This is just a quick summary of all the notes that were went over on the day we did this. Hope this helps.